We can do it a number of ways. The easiest way is through our software, where we have pre-written recipes, PC pump, PC vent. I'm going to run that now, and I'll show you how we can run things singularly or by turning the components on. Everything's protected with interlocks, so if you do something in the wrong fashion or the wrong manner, it's not going to damage the equipment. It's going to throw an interlock. It's going to prevent you from doing that operation. So I kept making this mistake yesterday. The majority of our tools are touch screens, except the Nano. This is just a laptop.
That's awesome.
I'll be counting how many times you try to touch it.
Yeah, she's actually keeping tally. I'm like, why won't this work? I'm like, oh, wait a minute.
Nice.
So you look over on the right-hand side, we have PC pump, PC vent. So PC process chamber. Click that, and a recipe screen will pop up. The first thing it's doing is executing each line of this here. And we have a program written called PC vent preparation. Basically what that does, if a power supply is on, it turns it on. If it has a set point of anything greater than 0, it sets it to 0. If it's rotating, it stops it. If the shutters are open, it puts it in a safe state.
Right.
And it executes this, and then when it's done, you'll notice you hear some air lines moving. High vac valve closed. Give it a couple seconds. We give it a few seconds because we want when the valve closes, the filament turns off. We don't want to shock the filament and burn out of filament.
Okay.
PC vent valve opens up. You see the system pressure is going up higher now.
Yeah.
So, keep wanting to touch that screen and move this. But I wanted to show you a few things here. When the ion gauge was on, this right here, IG, ion gauge, was reading over here. Since the valve is closed, we're reading the convection gauge. So if I hover over this, you'll notice a pop-up appears for a few seconds.
So what is CG?
Convection gauge.
Convection gauge.
Yeah, so the convection gauge works with about from atmosphere to 1 on 4. The ion gauge is really 1 on 4 to whatever ultimate vacuum you can achieve in this pool, which is probably the mid 7 range. But what I wanted to point out is, these are both displayed within here. So we have in our software what we call a series of conditions. So based upon the state of something, in this case being the state of the isolation valve, the high vac valve, that it's either going to read from the convection gauge, or if the conditions are right, it'll read from the ion gauge.
Right. Okay.
Since this is closed, we're reading from the ion gauge. And then these numbers are exactly the same. So convection gauge, ion gauge, we call this the wide range gauge pressure. So wide range gauge. So, but you'll notice whatever is displayed here will be displayed over here. So the recipe's complete. Take this. I just need to open it up enough, and then swing it out of the way.
Right here? Okay. Yeah, sorry, we're bumping the walls in here.
So you have 2 guns within this tool, source 1 and source 2. You have a 3-gun base plate. You'll notice there's another hole over here. In the Lesker scheme of things, depending on the configurations you have, if this was, let's say 6 o'clock, right in the front, if there was a gun right here, that's number 1.
Okay.
If there's nothing there, and there's a gun exactly to the left, that's number 1.
Okay.
So 1, 2, 3.
Okay.
You have a flatten within here with a multi-site holder, and you have you have a quartz ball heater, actually 2 of them. Let me get a pair of gloves on, and I'll actually take the flatten out.
Yes.
I got it.
How much experience have you guys had with sputtering? Years
That tool right there from the 1980s.
Okay.
And I think
Nothing inside should be touched with just hands.
Yeah, you actually want to use gloves.
I know I stumbled
Okay.
across another lab.
So,
on the
a
other
couple
corner
things
of the building,
here.
Which had like an old Lester Bell jar and an AJ8.
So this is our software. We're going to go through this pretty exclusively. If I'm on the deposition screen, this area here deals with substrate rotation. I want to change this speed to something very slow. And I'm going to go ahead and jog this. When I jog it, you notice that this is going to turn.
Okay. Oh.
Okay. And I want to do it in a certain manner. So you notice how this is cut out right here?
Yeah.
I want that cut out to face the 12 o'clock position. So if I can just take this like this and bring it back. This just rests on these two pins here.
Right.
That's what it does. It's a multi-site holder. So you'll notice there's a cascading bolt pattern around where these clips go. So I don't know if you can use wafers, slides, you know, whatever you want to put. You can kind of mount those to the front surface of this, and you know, we use the 4-inch wafer whenever we ran the test.
So the position is done on this.
Yes, yeah.
I mean the target is.
Yep. So let's go to the. I keep wanting to touch that screen. So I mentioned earlier, source 1 and source 2. So if I click this. This is your shutter that has just opened on source 1.
Nice, okay.
And source 2. So they call this a compact dome shutter. I'm going to take a few things off. I'll show you what they are. So this component right here is a cross-contamination shield. You do this so if you're running a second gun, you set it high enough, you don't get contaminants from the one gun onto the second target. And it's basically some thumb nuts. You can adjust the height through the slots. This compact dome shutter in the same manner. There's a pin, or the threaded portion. You can adjust the height. Now, something I wanted to show you, and I pointed this out yesterday, depending on the vendors who we purchase products from, you notice that there's a small recess within this. So really not a big problem on here, because I don't know if you guys ever worked with trap volumes and systems. So if you have a blind hole that's not vented and you evacuate a system, there could be trapped gas in there and it's continually trying to come out through the threads.
Right.
So you either have a vented hardware where you put a score along the side of the threads to give it a path to escape. You look at these two, one has a cavity, the other doesn't. So in this case, and it's really from, you know, Lesker's doesn't manufacture this. We buy this,
Right.
buy the gazillions from somebody. You know, if they change, then I put this on, not with this portion facing the trap volume. I just spun it around.
Yeah, okay.
So I just wanted to point that
Right
out.
on. Yeah.
Okay, so let me get some tools here. I apologize. I never remember if this is SAE or metric.
I understand. Moving back and forth hurts
Yeah,
your brain enough.
so I have both.
Yep.
So they call this the dark space shield, and it's just held on with this button head screw. I'm only going to take this off about 3/4 of a turn. You don't have to fully loosen it, because you just lift it up.
Oh, okay.
So if you take it out, it's just hard finding where it goes back. But you notice that there's two different depth slots on here. And there's basically, one's for a 1/8 inch target, a thinner target, and one's for a 1/4 inch target. So the 1/8 inch target, you want this lower, 1/4 inch target, you want it to sit higher.
Okay.
So dark space shield, and then this is your target.
Are those in some manual? Are those in the operational manual?
Yes, yeah.
Okay.
So this was the target that you bought the other day. So,
aluminum?
yep. So what I did, and I like to do this because all targets look the same, I scribed the name on the back of it. AL.
Good idea.
Because it's like the shell game when you get them all mixed up, you don't know what material it is. So I would strongly suggest you do that. But how this attaches is pretty simple. It's basically a magnetic keeper. So you have an outer magnet and an inner magnet within the tool. You may want to take a picture of that. That copper piece is your cooling ring. The back of the target is drilled and tapped for this keeper. And it's just magnetic attraction. It holds it in place.
Right on.
So pretty simple. Some of our previous designs had a clamp down style. We took hardware, and then, you know, depending on a number of things. You could sometimes sputter the clamp ring, but we didn't have that with our design. But I just wanted to show you what's involved in changing a target. So it's pretty simple. Now I brought another target with me. This is the used one in the back. So you can see the racetrack within this one.
Right.
And this one's new, so whenever you start to get some wear on it, you're going to get a erosion groove such as that. So one of the questions I get asked, well, okay, Brian, how long can I use the target before it expires? That's really a great question because I don't know what your process entails. But what I can tell you is that through our software, and I'm going to show you, we have the ability to track kilowatt hours. And I spoke to our applications department a few weeks ago because I had a similar question. And he said that, hey, let's track it every 1,000 kilowatt hours and see where the erosion is. And then we'll set a threshold or a limit based upon that. So, and I'll show you how to do that software-wise. But so within the chamber, I mentioned the guns. So there is it's a split clamp design on the bottom here, and underneath that clamp is an O-ring and basically a backing plate that actually compresses the O-ring when it clamps down, and that's what creates the vacuum seal. So you can notice that I could loosen this and I could bring this gun up. So we call that insert distance. So from the base of this chamber to the underside of this clamp, that's our insert distance. You'll notice that if I took I think it's a 10 millimeter wrench, I can loosen this and I can change the head angle, the pivot. So that's our angle adjustment. We use a setup where it's kind of like for best case, like the Russian nesting dolls, where the small pieces and larger pieces. There's a laser in it. So we have it for 2, 3, and 4 inch guns. So we sell a multitude, and then we can shoot that laser, and we can make sure that we're clocked correctly. So, for your operation, unless you take this gun out, you shouldn't have to change anything here.
So this will be vertical.
Well,
okay.
this one's not vertical. It's aimed to the center point of the chamber, but and what I mean by that is, as I was explaining earlier, it's sort of like clock hands. So you always want to be aimed to where